In this video, we will try to solve these three questions. We have to prove these three by applying sum and difference formula of sine and cosine functions. So if you're not aware about that, please refer to the first 5 videos in this playlist. It will give you an insight into how to apply it and why these formulas are important to solve trigonometric function questions. So let's start with the first one. Here we have to prove that sine square n plus 1a minus sine square na is equal to sine of 2n plus 1 times sine a. This is a very unique problem. So here if you notice on the left hand side, this is of the format a square minus b square. So a square minus b square is a plus b times a minus b. So this gives us a hint that we should approach this as sine of a plus b multiplied by sine of a minus b. So now what is the result of sine of a plus b multiplied by sine of a minus b? Let us try to solve it. So sine of a plus b is sine a cos b plus cos a sin b multiplied by sin a cos b minus cos a sin b. Now this is a plus b and a minus b. So we can apply the formula as a square minus b square. So this is sin square a cos square b minus cos square a sin square b. Now let us apply the trigonometric identity sin square b plus cos square b is equal to 1 and replace cos with sin. So we will get sin square a times 1 minus sin square b minus 1 minus sin square a times sin square b. So this would be sin square a minus sin square a sin square b minus sin square b plus sin square a sin square b. So we can cancel this out. So this is nothing but sin square a minus sin square b. So what we understand is that if we multiply sine of a plus b multiplied by sine of a minus b, then the answer is sin square a minus sin square b. Now let's apply this logic to the question. So if in the question a is equal to n plus 1 times a, so this is the first angle. Let's consider this entire thing as a. Then if b is equal to na, correct? Then what would be the answer for this question? So we would get, let's apply it as sine of a plus b times sine of a minus b. So we would get sine of n plus 1 times a plus na, that is our first thing, multiplied by sine of n plus 1 times a minus na, correct? Now how can we solve this? Let's simplify this further. So we would get sine of, this would be, if you multiply this, we would get na plus a plus na multiplied by sine of na plus a minus na. So the first term would be 2na plus a times sine of, we can cancel this, sine of a, correct? Did we do the right thing? Yep. I think so. Now, in the first part, we can consider a as common. So this would be 2n plus 1 times a and multiplied by sine a. So that is the proof that we wanted. So please keep in mind, let us add this to our formula sheet. Whenever we multiply sine of a plus b times sine of a minus b, we will get sine square a minus sine square b. And in the previous video, we have found a similar proof for cos of a plus b multiplied by cos of a minus b. We will add that too in the formula sheet. So this is the formula sheet we are maintaining. Let us add those two formulas we found, which is cos of a plus b multiplied by cos of a minus b. This would give us cos square a minus sine square b. Please watch video number 12. We have a proof and a detailed application problem to understand this. Then the next one which we understood is related to sine of a plus b multiplied by sine of a minus b. This will give us sine square a minus sine square b. Okay, our formula sheet is updated. Now let's try to solve the second problem here. Here we have to prove that sine of a plus b plus sine of a minus b divided by cos of a plus b plus cos of a minus b, this is equal to tan a. So let's apply the formula here. Sine of a plus b is sine a cos b plus cos a sin b plus the sine of a minus b formula now, which is sine a cos b minus cos a sin b. So divided by, let's apply the cos of a plus b formula, which is cos a cos b minus sin a sin b plus cos a cos b. Now I am applying the cos of a minus b formula plus sin a sin b. Now let's see if there are any terms that can be cancelled out. So in the numerator we have cos a sin b and minus cos a sin b. And in the denominator we have minus sin a sin b and plus sin a sin b. So this would change to 2 times sin a cos b divided by 2 times cos a cos b. Now we can cancel 2 in the numerator and denominator as well as cos b. So the answer would be tan a. Let us solve the third question now. Here we have to prove that sine of a minus b by cos a cos b plus sine of b minus c by cos b cos c plus sine of c minus a by cos c cos a, this is equal to 0. So here let us apply the sine of a minus b, which is the difference formula of sine, on all the 3 parts here. So which is, in the first part it would be sine a cos b minus cos a sin b divided by cos a cos b, and in the second part it would be sin b cos c minus cos b sin c divided by cos b cos c, and in the third part I'll write it in the next line. So in the third part it would be sin c cos a minus cos c sin a divided by cos c cos a. Now let's divide each term individually. So we would have, so I'm dividing this term with the denominator. Then also I will divide the second term with the denominator. So let me clean that up. Okay, so we would get, so if you observe here, in this, the first division, the cos B would cancel, correct? So we would have sine A by cos A. Only this part would remain. So it would be tan A. Then in the second part, cos A would cancel and only the sine B by cos B would remain. So we would have minus tan B. Now let's focus on the second part. So here cos, in the first term, cos C would cancel. So we will have plus tan B. And in the second term, we would have minus tan C. Similarly, in the last set, cos A would cancel. We will only have sin C by cos C. So this is plus tan C. And sorry about that. And in the last part, cos C would cancel. We would have minus tan A. Now let's see what can be cancelled here. Tan A and minus tan A, minus tan B and plus tan B, and minus tan C and plus tan C. So all of them get cancelled and we would have 0 as the answer. So this is how we can approach all these problems. Please memorize those formulas which we have added in the sheet. It will be very helpful for you to solve these questions. Thank you so much for watching. Please share this video with your friends and help them out too. I'll see you in the next video.